everybody that's attending the webinar, if you could just drop your email in the chat, we'll be able to get you your 1 hour, your credit, your CE credit.
All right, so we're about to get started, and I'm about to start since it is 11 a.m. Thanks everybody for joining. My name is Alex Zamzis, technical engineer here at Belzona, Houston. We do these every first Thursday of the month, and we'll have a little presentation here going about 15-20 minutes. If you have any questions during the presentation, just put them in the chat, and at the end of the presentation, we'll cover all the questions. If you want to go into something in further detail with our team, we can also schedule, one-on-one with your team, go over some specific applications. And just thanks everybody for joining in on your lunchtime. This presentation is going to cover CUI and some of the solutions we have. CUI is a big issue. We definitely see it a lot here at Belzona, a lot of repairs. Industry leaders estimate that CUI accounts for about 40 to 60% of pipe maintenance and about 10% of the entire budget. So I know several companies we've been working with lately that are really going on big CUI campaigns. It's just the type of corrosion that hides underneath that insulation and sometimes can build up over time without knowing, because it is tough to inspect. So we do have some products that can really help you guys maintain your asset integrity and also restore it to make it worth running your equipment. As far as CUI protection, definitely gonna differ with what type of application we're dealing with. We do have our normal products. So if it is an application that's at ambient temperatures up to about 120, we have several different products that can work. So this is a situation where you found CUI, you were able to shut down, or you were able to get to your turnaround, the equipment is down, or it just doesn't operate at elevated temperatures. For the most part, we're assuming that if it's insulated, it's operating at elevated temperatures. So if you're in a turnaround or it's shut down, we have a lot of different products that can work. Some of our most cost-effective are going to be Belzona 5811, Belzona 5831. We'll get into those products later. However, if you're not able to shut down and you are operating at an elevated temperature, a normal epoxy system is not going to really work. Normal epoxies, your application range, upper range for substrate temperature during application is around 120 to 140 F. So if you're in that temperature range, 170 to 300, and that 300 C should be 300 F there, you need a special type of heat activated epoxy. And that's what we have. To throw out some numbers, Belzona 5841 and 5851 are our heat activated products. So if you're running and you find a CUI, you do, pull back some insulation, found a pretty bad defect, but you can't shut down, or you don't want to shut down, you want your production to keep going, we have products that can be applied at those temperatures with minimal prep, repair corrosion, prevent corrosion, keep your operation going. Now we also have encapsulation of insulation. So Belzona 3211, this is a membrane that can be used to encapsulate insulation in those areas that lead to a lot of leaks and corrosion under insulation. So we'll get into that one. And not really covered in this presentation, but we do have a tank-based seal product that can stop, not really a CUI scenario, but similar problem with water getting underneath tanks. So we have a seal tank system, which we're thinking about going into in the next month's webinar. So starting with our heat activated, let's start hot. So our heat activated products, these must be applied directly to hot surfaces between 158 and 302 F. They do require just a minimal surface preparation. So SP2 hand tool prep is probably the most minimal surface preparation that's needed for coatings. So that's just taking off any loose rust, any loose paint with a wire brush. So it's very minimal. Won't need a hot work for that. And we do have testing, which I'm going to go into. So these are products that can be applied at hot temperatures with minimal prep and will provide you that corrosion resistance. So to go into the adhesion, so the way these work and the reason why we don't need that much surface prep is the adhesion onto hot surfaces involves penetrating the pores. The pores are going to be a little bit increased because of the temperature of the metal. So they're able to get a little bit more penetration into the pores and get a nice anchor bond. And some of the testing we've seen, so this is at the lower temperature range of the heat activated material. So this would be the 176. And when it's at 302, you can see our adhesion is actually better when it gets a little hotter. The only time it does not get better is when it's blasted. If we're blasting, we're still going to be top of the line either way. But you can look at here a rusty surface, 830 psi adhesion and 1380 psi adhesion. That is more adhesion than your typical external coating. Our Belzona internal liners, you're looking at anywhere from 3,000 to 5,000. That's with a perfectly blasted surface. This is, manually abraded, wire brush. This is very minimal prep, and we're still getting very good numbers for the type of application needed. So going into an example, refinery condensate vessel. So suffering from extensive CUI. They caught it in time where it wasn't an integrity issue, but they didn't want to shut down and they didn't want to allow it to further corrode because that would make an integrity issue. So we got it in time. You can see here he's just doing a wire brush prep. Especially for a tower, large tower, this is going to make it easier. You don't have to bring up large equipment. He's just taking his wire brush up with him, prepping the surface. Also, they have a pneumatic orbital, knocking off the loose rust. So this was operating around 90 to 110 C, so around the 194 to 210 F. And then we applied the product. So Belzona 5851 is a one component product. So there's no mixing involved. It just, once it sees that hot temperature of the substrate, it starts to cure. So you can see here, they're applying it around the top head and nozzle area, working their way down, and they coated about a third of the vessel or 2/3 of the way down. And you can see the temperature is a little bit lower down. The temperature of the vessel varied with the height. So there was a certain area where this product would not cure because it wasn't in the correct temperature range. So these products do have to have a minimum temperature for them to cure. But we do have products that will cure at these minimum temperatures, which would be our normal line of epoxies. So 12 months later, sorry, they went and inspected it. They were able to just take apart some of the insulation and do inspection, and the coating was perfectly intact. There was no more corrosion in these areas, and they saved this vessel from corroding extensively over time. So if you're not able to get to the vessel or equipment in time and your corrosion requires more of an integrity enhancement, we have different ways to do this. One way we do this is with what we call a plate bond, which is similar to like a lap welded patch. So in here we fabricate a metallic plate that fits the curvature or geometry of the substrate. We use our adhesive epoxies to bond them down and transfer the load from the degraded metal to the brand new piece of metal. So if your metal thickness is no longer suitable for the design pressure or loading, we can transfer the load from that degraded metal to a new piece of metal, that way, reinforcing the metal. So plate bonding is one way we do it. And this is, again, a hot application with the heat activated material. Another way we do it is using non-metallic composites. Again, this is our heat activated product, but this time we're going to use fiberglass embedded within it. And that's going to add some structural reinforcement. So you can see they're wrapping the fiberglass around the pipe, and it creates a non-metallic composite that's going to increase the hoop strength of the pipe and increase the pressure retention. It can even, stop leaks, prevent leaks, and reinforce the pipe section or vessel, tank, anything you need. So going into our encapsulation of insulation, that's tough to say. Your susceptible locations are going to be your penetrations, your T's, pipe supports, any tough geometry where the insulation is going to have issues with ingress, water ingress. So we see this a lot at nozzles, on the top of nozzles, stiffener rings. I mean, there's always those locations where you're going to see the most CUI. So what we have is a flexible waterproof material, easily applied. It's just hand applied, and it has a reinforcing sheet. And really what it's designed for is to hit those tough areas, those T's, bends, nozzles. So it's just going to encapsulate your insulation and waterproof it. It's also breathable, so it's going to allow any trapped water to evaporate and escape. So it is micro porous. It does allow vapors to escape, but it doesn't allow bulk water to move through. So it's used a lot of different scenarios, spheres, those tough areas, some, high risk areas is what you're looking at here, this sphere. You don't want any CUI here. You don't want any issues. So let's put an additional layer of protection above our insulation. So let's keep this acid running safe, running good, and running for as long as possible. So going into our protective coatings and composites, we're going to finish up on these three topics. Surface tolerant coatings. You're not always going to have a perfect surface. You might have oil on the substrate, you might have water, it might be sweating, different scenarios you won't be able to prep. So the CUI can be nasty at times, and it can lead to contaminated surfaces. So we have surface tolerant coatings. We also have ASME engineered wraps that can be used to restore integrity to severely corroded areas in CUI scenarios. And we also have insulating coatings that can be a replacement for insulation at times, and they're also corrosion resistant. So we're going to cover those three topics to end the presentation. And I do just want to mention, I'm showing you a lot of fancy coatings, surface tolerant, heat activated, ASME engineered wraps, insulating coatings. We do have our normal 100% solid Novolac epoxies. If you coat your equipment with this before it's in service or during a turnaround, or whenever we can get to it where the conditions are applicable, these coatings are designed for full immersion, excellent corrosion resistance, and a CUI scenario is a pretty easy application for them. So this would prevent your CUI in the future and reduce any impact it could have had. So starting with surface tolerant coatings. So you have oil or water. Normally, if I'm thinking CUI, it's a cold pipe that's sweating. You lift up the insulation, and it's got a lot more CUI than you thought, so you have a sweating pipe. The way these work is they have fillers that are able to displace moisture or displace oil. So they have special fillers that are able to remove that from the surface and get underneath it and go into the pores of the metal and get that good bond. So this is an application, sweating pipe. It was insulated before, and you can see the gussets are really corroded to the point where we could not even prep them because they were worried about the integrity. So we were able to use our surface tolerant epoxy combined with the reinforcing sheet, and we're able to get that good bond. And then over the top, we went with our strongest carbon fiber to really restore it back to where it needed to be and make it safe for the operators to turn this valve and work this equipment. So that's our surface tolerant solution there. So really the main focus, I would say, for CUI would be like a sweating pipe scenario. The next thing I want to talk about was ASME engineered wraps. So this is a scenario where it was a CUI issue. It wasn't operating at a very high temperature, so we didn't need the heat activated solution. We had a dry surface and we were able to blast. So we were able to install a system that's ASME engineered, designed to withstand a certain pressure and restore the substrate. And we installed an ASME engineered wrap that was on a Super Wrap 2, and it reinforced the wall of the vessel and made it suitable for the pressure that it needed to be, the design pressure. So this was applied in 2016, inspected in 2020, and it's supposed to make it to its turnaround in 2023 this year, in which they will do further investigation on the internals and revalidate it for either further service or further repair. So it is an API 510 approved repair. You don't always have to blast. I just do want to mention that it's also approved for power tool cleaning. There is a maximum surface temperature that has to be done. So the maximum surface temperature is about 140 F. Finally, I want to go into our insulating coating. So this could be a direct replacement for insulation at times. It's what we call a cool to touch. So you have a hot pipe, you apply several coats of this product, and now you have a cool pipe. So unlike insulation, it is a corrosion preventer and not a corrosion accelerator. This is a video that will demonstrate everything pretty clearly. So they have a hot plate. This is 3 coats, 2 coats, 1 coat, and no coats. And you can see the ice will be melting once it touches that. So it's a pretty simple, you know, when you're looking at it here, it's an insulating coating. As far as a direct replacement for insulation, it is not as thick as insulation, and therefore it does not provide the same amount of conservation of energy. So the situations where we've seen it used more is for personnel protection, which is what it was designed for. But there's also a lot of times where you have insulation for different reasons and it might work in that scenario too. So we just have to look at what you need as far as the delta T and what you're trying to achieve and see if this product works. And it also, on the other point, for cold piping, it could reduce your sweating. So on the opposite side of hot. So definitely an interesting coating, interesting applications, and that's all I had for you today. So I wasn't able to look at the chat during the presentation, but let me take a look now. And if there's any questions, feel free to unmute yourself and ask them out loud as well.
All right, man, I got a couple of questions about the products that you were talking about.
Yeah.
Okay, you're talking about your surface tolerant coatings and how they would displace oil and stuff like that. I find that kind of, I don't get that. Maybe it'll do it, maybe it won't. But the question I wanted to ask specifically on that is you indicated it can be used on a damp substrate. So my question is, how do you quantify that? When you say damp substrate, do you do that by how many degrees below dew point, or do you do that with how much a liquid is pooling on the surface? Is it something that's damp to touch? Is it something that's flooded? How do you quantify that, man?
I'd have to see it in person, but this product can be applied underwater. So it was designed for like a splash zone underwater application. So
right, we use international 954, or we use Carbomatic 615. There's a Tesla product, and they all say they do the same thing. But I will assure you that they will not all do the same thing. So that's the reason I had the question: is what do you deem as?
So there's one thing they are surface tolerant, but you still need a rough anchor profile for it to be able to get into the pores. As far as how wet it can be, I mean, we've done them sweating, we've done them leaking, and we've done them underwater. So be a good thing.
You've actually applied the coating. You've actually applied the coating underwater?
Yeah, it's been applied underwater.
Wow.
Why don't you let us, if you put your email in that chat, we'll send you our testing and we can give you all the information you need. But this is, anybody wants that, we'll certainly get it to you.
Cool.
And it'd be good to get someone out there to take a look at it and see what's going on, you know. And as far as the oil, you know, we can look at that too. I mean, if you have that scenario as well.
Yeah, but we won't.
Yeah.
But we might have some areas where we got a little of sweating substrate, and there's a multitude of different manufacturers that indicate that they got a material that will be successful in those conditions. And I found that if it's quantified basis, temperature below dew point, if you're 1 to 5 degrees below dew point, it seems like some products seem to work pretty good. And then if you get down where you're, 10 to 20 degrees below dew point and the liquid is pooling, and just, coming off the substrate pretty bad, then it makes it more difficult. So that was that question. And then I had a question about your insulator coating.
Yeah.
That 5871. 2 questions. Number one, I'm just curious about what the temperature needs to be of the substrate during application. Does it need to be, below 120 degrees? Or can it be applied at an
So
elevated temperature?
it can be applied all the way to 300, but
Wow.
your performance is going to be the best under 180, because the way it works is it once you apply it builds up in thickness. So you apply it at 10 mils, it'll turn into 30 mils. But when it's really hot, it cures before it can build up enough.
Right, right.
So it's gonna perform better. It just might need more coats if you're coating it at the hotter temperature.
Okay. But if we apply it in ambient, that would probably might be necessary. Ambient being, below 120, 140.
Yeah, it's gonna
Next question.
grow more, yeah, at that temperature.
10 for what's the maximum service temperature that material is good for
So it is
before it'll
again,
start
at the
responding?
302, and that's like with some safety factor. We've taken it a little higher, but the corporate is going to be the 302, and that includes like a little bit of a safety factor, but we've taken it to like around 350 with good numbers.
Perfect. Perfect. Well, hey man, I appreciate it. Thank you for answering my questions.
No problem. Thank you.
Yeah, I got one quick question for you. Now this seems like it's pretty specialized applications. Do y'all have your own like in-house applicators that can come and do this?
We sure do. And it seems pretty special. It is, but it also is not that complicated as well. So we do training for any contractor that wants to put their hands on Belzona. So we do it both ways. Does that answer your question?
10-4, thanks.
Thank you. All right. Any other questions, comments? Like I said, we do this every first Thursday of the month. If you have a topic that you want to cover specifically, we can tailor it towards that, or we can do a one-on-one with your team. And thanks everybody for joining in. If there's no more questions, we can call it a day. Everybody have a good weekend and stay safe out there.
Thank you.
Good stuff, man. Thanks.
Thank you.
Thank you, sir.